Today, today we will see how to construct a radial wave function. The total wave function psi is sub NLM, which is a function of r, theta, and pi in spherical coordinate, can be written as the product of two wave functions. One depends on r, that is r NL. It is one is depends on R alone, that is R sub NL, which is a function of R, and YLM, which depends on theta and pi. So L depends on theta and M depends on pi. In this class, we will see how to construct a radial wave function. In the next class, we will see how to construct this angular wave function. Then if you multiply both, you will get the total wave function. With the radial part of the wave function by definition is equal to 1 over r rho L plus rho power L plus 1 e power minus rho uh, v of rho. Here we have to solve one by one. Rho is given by rho is given as rho is equal to r over a n, where n is the principal quantum number. This n is principal quantum number, so we can substitute this here, and as well, uh, here you have rho, here you have rho. V of NL can be substituted from here. To find this, see here you can find rho easily. That is rho is equal to R over AN. Then V of rho can be found by calculating this coefficient Cj. So by definition, C sub j plus 1 is equal to uh, 2 times j plus 1, j plus L plus 1 minus n divided by j plus 1 multiplied by j plus 2L plus 2 Cj. So first you calculate this, then you find the summation over all the coefficient. Of course, you know rho here also, you can substitute it and calculate. Here we will see three examples how to calculate the radial part of the wave function. Now we can find the radial part of wave function for n equal to 1 and L equal to 0. So by definition, RNL is equal to 1 over R rho L plus 1 e power minus rho V of rho. Here you can see rho by definition it's equal to R over AN. Here n is equal to 1, so this rho will become, here I will concentrate this rho. Since L is equal to 0, this is simply will become 0 plus 1 rho. Rho is equal to R by A, that I have written here. Then here you can see additional, in addition already there is 1 over R. This R and this R will cancel out. So naturally, this will become 1 over A. So 1 over A e power minus R over A, sorry, e power minus R over A V of rho. So now we have to find V of rho. As I said, V of rho is by definition summation over j equal to 0 to infinite Cj rho j uh, Cj rho j. In this case, we will see what is by definition Cj plus 1 is equal to 2 times j plus L plus 1 minus n divided by j plus L multiplied by j plus 2L plus 2. Now you take the numerator. What is j in this? In our case, is first you take j equal to 0. J equal to 0 means this will become C1. So the first j is equal to 0. I have written like this. Then L is 0. We have taken L as 0. then 1 minus n. Here n also 1. N is equal to 1. 1 I got. So here see the terms inside the bracket. 1 minus 1 is 0. So this will become 0. That is C1 become 0. So all the coefficient after C1 will get cancelled. Only C0 exists. So by the definition of V of rho, we have to write summation over Cj rho power j. Here when j equal to 0, this will become C0. Then rho 0 is 1. So this will become simply C0. So now this equation can be written as R10, which is a function of R is equal to 1 over R e power minus R over A. This V of rho will become C0. This is our wave function. Now we have to normalize this. Now we have seen that R sub 10 of R is equal to 1 over A e power minus R over A C naught. This is C naught. Now we have to find the normalization constant. This is three. Remember that this is three-dimensional one. So now for normalization, we have to integrate between 0 to infinite, not minus infinite to infinite, 0 to infinite. This is a three-dimensional case, spherical polar coordinates. That is the reason why it is 0 to infinite due to symmetry. So modulus square of R10 R square dr. This comes because this is a three-dimensional integration. That is t 3r is equal to r squared sine theta dr t theta t pi. Here we are taking only the radial part. That is r squared dr. So that comes here. So you have to integrate this. Now you replace the radial part of the wave function, which is C naught divided by A. So if you square it, then this will become C naught squared over over A squared integral between 0 to infinite. This R squared e power minus 2R, because we are squaring it, e power minus 2R over ATR must be equal to 1. Here this is the standard integral, that is r power n e power minus alpha r tr is equal to n factorial divided by alpha plus n alpha power n plus 1. Here alpha, you know that alpha is equal to, in our case it is 2 pi a. 2 pi a is alpha. So 1 over alpha 1 over alpha power n plus 1. N is here 2. 2 plus 1 is 3. That is equal to a divided by 2 whole power 3. Then since r is n, this is n factorial. So n factorial is 2. So that 2 factorial is 2. Then this will become a divided by 2 whole cube. This 2 factorial I have written as 2. Then this will be a cube divided by 8. So this and this will get cancelled. You will get 4. And the a squared a cube will become simply a. So this will be c naught squared a over 4 is equal to 1. Or C naught squared a over 4 is 1. C naught is equal to 2 over square root of a. So now the normalization constant we have found. You replace this C naught. Already there is 1 over a, here 1 over square root of a. Then this will become a power minus 3 by 2. Already there is 2. Then this exponential term will come. So this is the normalized radial part of the wave function. Hereafter we are going to avoid that normalization process. Just we will find the radial part of the wave function. And now we will see the wave function for R sub 20 of R. The basic definition for R n L equal to 1 over R as usual, rho power L plus 1 e power minus rho v of rho. Here you replace, here n is equal to L equal to 0. So since n equal to 2, rho is equal to R over 2a. So I have replaced this. Here L is 0, 0 plus 1, 1. Rho power 1 is simply rho. So rho will be R divided by 2a. Then here also rho is replaced by R divided by 2a. And V of rho we have to find. Here you can see this R and this R will get cancelled. So this will become 1 over 2a e power minus R over 2a V of rho. Now to find V of rho, as usual, we need this coefficient. J plus 1 is this one. Here C1, because j equal to 0, uh, 0 plus 1 is 1. C1 is equal to, here j is equal to 0 and L also equal to 0. J equal to 0, L also equal to 0 and plus 1. Here n is minus 2. Sorry, n is 2. So this will become minus 2. So 1 minus 2 is minus 1. Here you have 2. 2 into minus 1 will become, the numerator will become minus 2. Then what about denominator? This one, j equal to 0, 0 plus 1 and j equal to 0 and L also 0. So this plus 2, this plus 2 comes here. This is 1 into 2. So denominator is divided by 2, which will give you minus 1. So this C1 is equal to minus C naught. What about C2? C2, for the case of C2, j equal to 1. So in order to have, so I have replaced j as 1, L is 0 and plus 1, n is n is 2. Similarly, j is equal to 0, uh, j is equal to 0, and here before going into the numerator, you just see the denominator. This is 1 plus 1, 2, 2 minus 2 is 0. This numerator is 0, so even you need not calculate the denominator. So this will be 0. C2 will be 0. So you have only C naught and C1. Now we will find the mu of rho. By definition, mu of rho is equal to summation over Cj rho j. J runs from 0 to infinite. Now we got only two coefficients, that is z0. When j equal to 0, this will become z0, rho 0 is 1, so z0. When j is equal to 1, Cj is equal to 1. And j, since j is equal to 1, this row will become just row. So this one second term will be c1 multiplied by row. From c2 onwards, this coefficient vanishes. However, we have seen that c1, this c1 is equal to minus c naught. C1 is equal to minus c naught. So now you take C naught as common. This will become 1 minus rho. Rho is, we know, R divided by 2A. So this is the case. Now the general definition for the radial wave function is 1 over 2A e power minus R over 2A rho of R. Here rho of R is C naught. You take the C naught times 1 minus R minus 2A over 2A into e power minus R 2A. So here you have to find the normalization constant in usual way. I am not going to do it because it's a straightforward. So that normalization constant divided by 2a is equal to this one. 1 over square root 2 a power minus 3 over 2 1 minus this term and exponential term. This is the radial part of wave function for n equal to 2 and l equal to 0. Now we will see the radial equation for 2 1. Now we are going to see the n when n equal to 0 and n equal to 2 and l equal to 1. So as usual, R NL of R is equal to 1 over R L rho power L plus 1 e power minus rho V of rho. So here n is equal to 2 as usual. So rho equal to R over A n. N is 2, so this will become R over 2A. This R21 is equal to here L equal to 1, that you have to remember. So L equal to uh, 1. So this will be rho squared. So rho squared is R squared over 2A squared. That is, this is R squared over 2A squared. Sorry, 4a square. 2a will become, if you take a square, then 2 squared will become 4 and a square. So 1 over r squared over 4a square, because it's a rho square. E power rho, as usual, e power minus r over 2a. Now we have to find the v of rho. Before that, we can simplify this. R squared, R will get cancelled with this R squared, this will become simply R. So this equation can be written as R over 4a squared e power minus R over 2a V of rho. Now we have to find the V of rho only. So to find V of rho, we have to find the coefficient as usual. C j plus 1 is this one. So here j is equal to 0. First coefficient C1, j equal to 0, and L it is given 1. So here j equal to 0, L equal to 1, L equal to 1, already plus 1 minus 2. Here you can see 1 plus 1, 2, 2 minus 2, 0. So this will become, numerator become 0. So this j equal to 0, so C naught will be equal to this C1 will be equal to 0 naturally. C1 equal to 0. So here also only two coefficient. One is only one coefficient, that is C naught. C1 is equal to 0 and all other term also 0. So V of rho is equal to summation over j 0 to infinite Cj rho power j. J is equal to 0, rho power 0 equal to 1. So this is C naught, simply C naught. Because C1 vanishes, becomes 0, only one coefficient. So this wave function can be written as here you see. V of rho is equal to C naught as per our thing. This is C naught. So this can be written as C naught over 4a squared, and this exponential term R e power minus R over 2a. Now our problem is to find the normalization constant C naught. So usual method, you can calculate it, and you can find C naught divided by 4a squared is this one. That is so 1 over 2 square root of 6 a power minus 3 over 2 r into exponential r minus 2a. So this method is a normalization usual method you adopt. I don't want to repeat it, but it's simple and straightforward. So this is the way to construct the radial part of the wave function. Thank you very much for watching my video and supporting me continuously.